So in this lesson, we're going to go over graphing radical functions. I'd like you guys to go ahead and do these two warm-up problems and then come back to me when you're done. So pause the video, do these, and come back to me after you've chosen your answers. All right, so on this first one, y'all, we are going to square both sides because that's how we get rid of the square root, okay? So that's going to give us over here, that means that this cancels out the square root. The square cancels out the square root, so we're going to get x minus 1. And that's going to be equal to, and remember, if you don't remember what this is, you're going to do x and minus 3 and x and minus 3 in the box, right? So this is going to be x squared minus 3x minus 3x and 9. So you see our like terms right here, okay? So that's going to give us x squared minus 6x plus 9. Now we have to subtract the x from the left, and we have to add the 1. Okay, so that's going to give us x squared minus 7x plus 10. Now we must factor this, okay? So we're going to factor, what are the factors of 10 that add up to be negative 7? So that's going to be minus 5 and minus 2, right? Now remember, we're going to set both of these equal to 0. So this is going to be x equals 5. And this is going to be x equals 2. Now also recall that we have to check both of these in our original problem up here, okay? So that's what we're going to do. So we're going to now check and make sure that this works in both of them. So we're going to do the square root of 5 minus 1 equals 5 minus 3. 5 minus 1 is 4, so the square root of 4. That equals 2. Yes, 2 equals 2. So we know that that's one of our answers for sure. Now let's check the other one, okay? So now we're going to do 2 minus 1, and this equals 2 minus 3. So that's going to be the square root of 1. This is equal to negative 1. That's 1, negative 1. Nope, that does not equal, does it? So this is what we would call an extraneous solution, right? So it's not our solution. So the answer is B, okay? Now, if necessary, pause the video and go ahead and do the other one and then come back to me. All right, so now on this other one, what we're going to do is we're going to do the reciprocal of 2/3 and take it to that power to get rid of the 2/3. So it's going to be 3 over 2 here and 3 over 2 here. And you can put that in your calculator, but that really is the square root of 25, which we know is 5. And then 5 to the third is 125. So this is going to be x squared plus 4 equals 125. Then we're going to subtract 4 from both sides. So x squared equals 121. Now we're going to take the square root of both sides, right? And remember, when we take the square root over here, there's going to be a plus or minus in front of there, right? So this is going to be x is equal to plus or minus 11. So the answer was C there, okay? All right, so the lesson today, this is what we're going to do. We're going to answer the question, what is the visual representation of a radical function? And we're going to find what is the domain and range and transformations of radical functions. So that's what we're going to do today. So the very first thing here says compare the graphs. So I also want to write up here that when a is f of x equal to the square root of x, well, remember, this is also equal to x to the 1/2 power, right? So now what I'm going to do is I'm just going to build a table here so that I can graph this. Now, obviously, you could put this in a calculator, right? You can build the table function, but I'm going to actually just build a table right here, and I'm going to put some values in there, okay? So I got an x and a y. So let me ask you a question. Can I take the square root of a negative number? No. So I'm going to start with 0 here. Square root of 0 is 0. I could put 1 in there. What's the square root of 1? 1. What's the next perfect square? Yeah, 4. So we can put 2 in there. And then we can put 9, right? Square root of 9 is 3. Okay, so let's go ahead and plot these points now. So we've got our 0. 1 is 1. Then we've got 4 at 2. And then we got 9 at 3. So this is the graph of a square root function right there, okay? Now, let's talk about domain and range. Domain are the x values. So we're talking about the values here. So our domain could be stated as what? x is greater than or equal to 0, right? Or we can do it this way, okay? So it includes 0, so we could put a bracket here, 0, and it goes on to where? Infinity. So this is two different ways we could write the domain, okay? The range is the y values, right? So on the y values again, we're going to start at 0 and we're going to go up, right? So y is going to be greater than or equal to 0 as well. So once again, this would be our starting point is 0, and it includes 0. That's why there's a bracket there, right? And then it goes on to where? Again, positive infinity, because it's going to keep going up and up and up and up, right? And it does never end, okay? So now let's talk about cube roots. So this is equal to what? X to the 1/3, right? So remember, these are interchangeable. The square root of x and x to the 1/2, the cube root of x and x to the 1/3. So here again, I'm going to build a table. And I'm going to start with a value over here all the way to the left, as far to the left as I can go. And I'm going to start with -8. And that's just because it's on my table, right? So if I take the cube root of -8, I get -2. If I take the cube root of -1, I get -1, 0, 0, right? Now, you could put this again in Desmos and actually see this graph and then pull a table, okay? So then we got 1 and 1, and then we got 8 and 2. So let's go ahead and graph this. So at -8, we've got -2 right there. At -1, we've got -1. At 0, we're 0. And then at 1, we're at 1. And then at 8, we're at 2, okay? So now notice how this graph curves. Y'all see this? So this graph's going to start out here, and it's going to come up through here, and it's going to go out the other side, okay? So now you should notice something very different about this domain and range. Now look over here at the square root one. That one had a starting point, right, and then turned towards the right. However, with cube root graphs, they're going to go on forever, right? So when we talk about our domain, it's going to be all real numbers. Remember, that's the symbol for all real numbers. So if we were to write this again in our brackets, it's going to be from -infinity to infinity, right? And then our range, again, all real numbers, and our bracket again, because it's going to go up and down, right? So it's going to go down forever, it's going to go up forever. Remember, range is our y values. So this too is going to go from -infinity to infinity, right? That's our range. So now when we talk about graphs of radical functions, they can be transformed using methods similar to those that transform quadratic functions. So if you remember, this is a quadratic function here, and we had an a and an h and a k, and they represent a variety of things. So when we have a -a, that is a reflection over the x-axis. So that's what we're going to write here, reflection over the x-axis. So if a is negative, it's going to be a reflection over the x-axis, okay? Now, when we start talking about the number that a is, not whether it's positive or negative, but if it's a number. So if a is greater than 1, then we have a vertical translation, or sorry, vertical stretch by a factor, S-T-R-E-T, I can't spell, y'all, T-C-H, by a, okay? Now, if a is between 0 and 1, which means it's a fraction or a decimal, okay, then it's going to be a vertical shrink, or we call compression. So we're going to say shrink, compression. They're interchangeable terms, y'all. Again, by a. Now remember, if this is the case, then a is going to be a fraction, okay? Now, h, if you remember, h is a horizontal translation, okay? So this is a horizontal translation. That means it's moving left or right. Okay, so I'm going to write horizontal translation. And I'm going to say if it's positive, it's going to move left. Because if you look up here, look at the equation. That's a negative, right? So we're always going to change the sign. And then if it's negative, we're going to move right. And that's going to be by whatever h is. Okay, so if h is 2, it's going to move 2 left. If h is negative 2, it's going to move 2 to the right, okay? Then we've got k is our vertical. This k represents vertical. Wow, I cannot spell today, y'all. V-E-R-T-I-C-A-L. Can't spell, can't write, can't talk. This one's a vertical translation. Now, this one is what it is because we have a plus sign up here. Y'all see that plus sign right there? Okay, so because of that, when it's positive, it's going up. And when it's negative, it's going down. And this is going to go up or down based on that by k. So now we have a square root, okay? And square root and cube roots, we're going to do the same way. So the a, the b, the h, and the k are going to represent the same thing, whether it's a square root or a cube root, okay? So first of all, we got a negative a here. So that means the same thing it meant before. So this is a reflection over the x-axis. Now, if we have a negative b, it's actually going to be a reflection over the y-axis, okay? Now, remember we talked about a before, so this is going to be the same as it was before. So when a is greater than 1, it's going to be a vertical stretch by a, okay? And if a is between 0 and 1, which means it's a fraction or a decimal again, it's going to be a vertical. And again, we're going to say shrink or compression because it could be written either way, y'all. They mean they're interchangeable terms again. Again, by a. And remember, that means a is going to be a fraction or a decimal, okay? Now, b. B is a little different. Y'all see this b up here right here? It's 1 over b. That means it's an inverse. So when we start talking about this, it's going to be a little bit different than what we've been accustomed to. So, okay? So whatever we have in this position of where b is, okay, we're always going to flip it. So if it was 1/2, it's going to end up being 2. If it was 2, it's going to end up being 1/2, okay? So if 1 over b is greater than 1, so if the number there is greater than 1, okay, then it's going to be a horizontal shrink or compression. So again, we're going to write shrink, compression. Now watch what happens. By 1 over b. Okay? So we're going to flip it. Now, if the 1 over b is between 0 and 1. So again, the whatever value's in that place where the 1 over b is, y'all got it? If that is basically, again, a fraction. Now this time it's going to be a horizontal stretch. I can't spell today, y'all. S-T-R-E-T-C-H. Wow, I can't write, can't spell. E-T-C-H. And this one's going to be by just the b, okay? So the key here, again, is to remember, whatever's there, you're going to flip it. So if it's 1/2, it's going to end up being 2 over 1, which is 2. If it was 3, then it's going to be 1/3, okay? Now, we got h and k are what they've always been, okay? So h is a horizontal translation, right? And this is going to be opposite of what's there because of that negative. Y'all see that negative right there? Okay, so it's always going to be opposite. So this one's going to be plus, it's going to move left, and minus is going to move right, and that's not what we would expect. Some people say if it's in the house, it changes, right? So if it's in the radical, things change, okay? So, and this is going to be by h, and then down here, k is going to be a vertical translation. Again, this one's going to stay what it is because it's outside the house. Y'all got me? So this is going to be plus means up and minus means down. Okay? That's what vertical means, right? Up or down. And this one's going to be by k. All right, so now we're going to do some examples just to check it out. So here's a couple examples of reflections. So the first one is if there's a negative in front of the radical, okay? So if there's a negative in front of the radical, then this is going to be a reflection over the x-axis, right? The next one is if there is a negative underneath attached to the x, y'all, then it's going to be a reflection over the y-axis. Now, we got an A. So that means there's something in front of the radical, okay? So if there is a number greater than 1, 1 or greater, 1, actually greater than 1, in front of there, then this is going to be what? A vertical stretch, okay? And this one's going to be a vertical stretch by a factor of 6. Can't hardly fit that there, okay? So what do you think the other one's going to be? Yes, this one's going to be a vertical shrink. Again, what's the interchangeable word there? Compression by a factor of what? Yes, 1/2. Okay? All right. The next one is a horizontal stretch or compression, okay? So this one, again, remember, if it's under the house, if it's in the radical, y'all, it's going to change, okay? So this time, this is going to be a horizontal. And it looks like it's a fraction, right? So it's actually going to be a stretch, y'all. Okay, and this one by a factor, remember, we're going to invert it, of 5, okay? So the other one, the 3 times the x, is going to, again, be a horizontal. Now this one's going to be a compression, or what else will we call this? Shrink by a factor of, again, if it's 3, we're going to say it's 1/3. Okay? All right, so now we've got a K. So we're going to go ahead and do the K, which is up or down, right? So this is vertical translation up or down. So on this one, we've got a, let's go back, I'm going to go back to green, y'all. So this is a vertical translation. How's it moving? 3 up, or 3 units up, right? Okay. And then what about the -4? This is going to be a vertical translation 4 down. And it could say units, y'all. So 3 units up, 4 units down. Let me fix that 3 so y'all can read it. Okay. Now, the K, the H. Now remember, the K doesn't change because it's outside the house. It's outside the radical symbol. Anything that's in the radical symbol is going to change, okay? Now, what's outside the radical stays the same. So we're going to go ahead and change the H. So on this one, it's negative, so what's it really going to do? Move. This is going to be right or left, y'all, okay? So H is horizontal, right? So this is going to be a horizontal translation. And this is going to be 2 right, or 2 units right, okay? So what about the last one then? This is also going to be a horizontal translation. And this one's going to be what? 1 left, or 1 unit left. So when we're talking about our domain and range for square root functions, the very first thing I need to tell you is that this point where the graph begins is at h comma k, okay? So if that's at h comma k, then when we're talking about our domain and our range, it is affected by that point. So that's where the graph begins, and what's happening to our x values? Well, they are getting less than and equal to than our h, and our y values are getting greater than and equal to our k. So when we graph the function, if it's headed towards the left, that's what's happening. And so if we were to write this in bracket form, then it's going towards infinity on the left, right, and on the right, it's going to be where h is. So we put a bracket there. Okay, remember there's always a parenthesis where the infinity is. This is headed towards what kind of infinity? Negative infinity. Y'all see that? Okay. So I guess I should have included that in there, but let me go ahead and erase this and do it again. So this is negative infinity because that's where it's headed, right, y'all? Okay, now what about our y values? So the difference with our y values is if we do our bracket, okay? So where did our y values start on the right? Where did they start, y'all? Because they're going towards the left, right? So this one, our y values, look, right here, bottom, they're going up, yes? So our y values are starting at bracket 0, and they're going up to where? Infinity. So there we go. Again, a parenthesis. So here again, this starting point right here is h and k, okay? So what's happening to our domain, our x values? Once again, they're getting smaller, right? They're going towards the left, okay? So and so when we write this one, it's going to be just like the last one. So we got our negative infinity, and on the right it's h, right? Now when we're going up and down, that's what we're talking about as far as y is concerned. So what's happening to y this time? Yep, you're right, it's going down. So this is going to be less than or equal to k. All right, so this time when we talk about it, where's this graph headed? So where did it start? Where did the graph start? Remember, we're talking about from up to down. So this one, again, started at 0, but this time it's headed towards where? Negative infinity, right? Okay, let's talk about the other two. All right, here again, this is h and k, right? So what's happening to the x values? They're getting greater than or equal to h, right? So when we write this one, the bracket is going to start at h, and it's going to go on to infinity, right? What about our y values? What's happening to the y values? They are also getting greater than or equal to k, right? So here, this one's going to start with k, and it's going to go on to infinity as well. That's like our parent graph, right? So the last one would be a reflection over the y-axis. No, the x-axis, sorry. So here again, this is starting at h and k. So this is going to be what? What's happening to the x values? They're getting bigger, right? So this is going to be greater than or equal to our h value again. And what's happening to our y values? They're getting smaller, right? So that's going to be less than or equal to our k. So how do we do the brackets again? So this is going to be again, sorry. My voice is going out, y'all. So this is h, starts at h, right? And it goes on to infinity. And then what about our range, our y values, y'all? What's happening to our y values? Where do they start? They start at k, and they head to negative infinity, right? Okay. So now let's talk about domain and range for cube root functions. So this is what our cube root functions look like, right? So if I was to draw my xy axis, it would be something like this. And this middle point right in here, y'all, is our h and k there, right? That's what moves it. Same way here, this would be h and k. Now the difference with this is that our domain and range for cube root functions, what happens? It's going to keep going up, and it's going to keep going down. So our domain is going to be all real numbers, and our range is going to be all real numbers. And the way we write that in bracket is from negative infinity to infinity, right? And what? What about here? So again, our domain and range, negative infinity to infinity, right? That's where they're going. Same way with what? So that's all real numbers here as well. All real numbers, all real numbers. So once again, from negative infinity to infinity, and from negative infinity to infinity, because it goes on. That's basically all real numbers, y'all. All right, so now we're going to do one example, or we're going to do two examples, actually. So it says describe graph, and find the domain and range of the transformations. So what we're going to do first is we're going to describe this thing. So what does this 2 tell us? The 2 tells us it's a vertical stretch by a factor of what? 2, right? Okay, and what does this -5 tell us? Isn't that a horizontal translation? Now remember, it's under the house, it's in the radical, so we're going to change the sign of it, okay? So horizontal translation by 5 right. So remember, it's always going to be opposite of what we think. So now we could actually do this right in Desmos and see what some of these values are. So I'm going to actually create a little table here so you guys can see some values. Okay, so X, Y. So I'm going to put 5 in there because I know it's going to start at 5, right, y'all? So how do I know it's going to start at 5? Because that is my H. Remember, I told y'all H equals 5, so that's where my graph's going to start, okay? So when I put 5 in there, I get 0. So 5 zeros right there. If I put 6 in there, I get 2. And again, I can put this on the graph, and it'll actually tell me that. So 6, 2 is right there. And then if we go, let's just go out to 10 because 10's out there. And let's just put one more value. Let's just do 10. When I put 10 in there, I get 4.47. So 10 is 4.47. So that's about 5. So this is about what this graph looks like, y'all. Okay. All right. So our domain. Now let's look at this graph. What's happening to our domain? It is going to be, X is going to be greater than or equal to, what is our H, y'all? Yes, 5, okay? And how would we write that if we were going to write it in brackets? We start at 5 and go on to where? Infinity, yep, okay? So what about our range? So let's talk about our range. So this, notice where it starts, y'all. What's our K? 0, right? So our Y is going to be greater than or equal to 0. And again, where are we going to start here at 0, and where are we going on to? Infinity, right? Okay, so let's look at this last one. So this is describe and graph the describe, graph, and find the domain and range of the transformations. Okay, so what does this negative out front of the whole thing tell me? Doesn't that tell me it's a reflection over what? The x-axis, yep. Okay, so this time I don't have an A and I don't have a B, but I do have this right here. So remember, if it's under there, we're going to change it, right? So that would typically be left or right, right? So this is going to be a horizontal translation. And we're going to say 2 units left, right? All right, so what about this last one right here, this -7? So that's going to be a vertical translation. What? 7 units, how? Down. Yep. So here again, now this is a cube root. Y'all notice that? So I wasn't even worried about whether it was a cube root or square root to talk about these transformations, right? Because they're the same for whether it's a square root or a cube root. But, so now let's go ahead and look at, now we know this one's going to go off to the left and off to the right. So the domain or range for this is going to be, of course my pen's going to stop working, all real numbers and all real numbers. And the way we write that is -infinity to infinity, right? And -infinity to infinity, okay? So now, let's just put some values in here. So again, let's create us a little table over here so we can see some values. And I'm going to do X and Y, okay? So let's do like, what? Let's do -8, okay? So if I do -8 in there, and again, I can do this in my table. I can just put it, I can just look at I can put this in Desmos, and I can look at what the value is at -8. Well, what I found was it's -5.2. So -5.2 at -8 is going to be about, we'll just say there, okay? And then one of the things that you guys need to notice is that this whole graph transitions to the left 2 and 7 units down. So to the left 2 and 7 units down is right there. That's where the curve of our graph is going to be, where it's going to change from going down or it's going to go down, but I'm saying it's going to transition there like the graphs have all along. So now let's also look at, so that was that, I knew that point again because that is where the center of the graph is at. So again, if I put -2 in there, I'm going to get -7 for my y, okay? Then let's do another point out here. So let's just say another 8 out here, okay? So when we put 8 in there, we get -9.2. So again, you can compute it, or you can put it in your graphing calculator, or you can put it in Desmos and just click on that point. So at 8, we got -9.2. So that's about there. So this is what my graph for this one's going to look like. It's going to transition right there, and it's going to go out that way, okay? So there we go.